So autocorrelation for a random process. So we have a random process x of t, and autocorrelation is given as rxx of t1 comma t2. This is equals to expectation of x of t1, x of t2. Now if I say that x of t is White's and stationary, then I can write rxx of t1 comma t2 as what? What I can write? Rxx of t2 minus t1. No? This is same as rxx of tau, right? So White's and stationary means I have to say like random process, mean is constant, and autocorrelation is coming as a time difference. Okay. Now properties for this, assuming that x of t is a White's and stationary process, autocorrelation function is this. So mod rxx of tau is less than or equals to rxx of 0. So this says that at origin it has max value compared to any other points. So autocorrelation is maximum at 0. Then we have rxx of minus tau is equals to rxx of tau. That means it says it's symmetric or even function. So that means luck is this, like if you have half thing is done, right, from 0 to infinite, if you do, that's enough for you to replicate at minus infinite to 0. If you find out half, that's enough. Okay. Now rxx of 0 is given as e of x square of t. See here, this is already a White's and stationary. Both points are t1 and t2 only. Same, t1 is equals to t2. So I don't get t2 minus t1 as some value. It will come as 0. Because this is equals to x square of t, mean square value. See, in this case, one example if I take, for example, a random process x of t is a voltage signal, or x of t is a current signal. Okay. See, if voltage, if I want to find power, the formula is v square by r. Okay. If I want to find power when current is there, it is I square into r. Okay. Now I am assuming resistance is 1 ohm. Okay. Then I can write power as simply v square or simply I square. Okay. For this, if I find expectation of v square or expectation of I square, it's nothing but I am finding the average value. That is average power. Yes, now. So E of x square of t means it says average power for the random process, assuming that resistance is almost 1, like that we assume. And E of x square of t for a White's and stationary process is same as autocorrelation when you substitute tau equals to 0. Rxx of 0, whatever the value is there, that is same as E of x square of t. Okay. Now the fourth property, if expectation of x of t is x bar and which is not equals to 0, and this is ergodic and no periodic components, that means it's not a periodic signal, then I can write autocorrelation as mod tau tends to infinite rxx of tau as mean square. Okay, so mean has some value and this is an ergodic function with no periodic components, and if you want to find the autocorrelation, it's nothing but mean square. Then fifth one, if x of t is periodic, then rxx of tau is also periodic with same period. Then sixth one, if x of t is ergodic, 0 mean and no periodic components. So before it was taken as same thing, okay, like this fourth property only, but this time I am saying this as 0. So then what happens to autocorrelation function is limit mod tau tends to infinite, Rxx of tau will become 0. So modification of your fourth property. Okay. So we'll take one example. So this is the problem. Okay. Rxx of tau autocorrelation function is given 25 plus 4 by 1 plus 6 tau square is given, and it says it's a stationary ergodic process with no periodic components. This is already given in the question itself. This is given. For this autocorrelation function, we have to find, or for this random process, we have to find what is the mean and variance. If I want to find mean, what's a formula I can use? I can use the fourth property, right? I can use this fourth property, okay? Because Rxx of tau is given here. So from this, I have to get this mod x. So this will be equal to 25 plus 4 by 1 plus 6 tau square to the whole square root. I'm saying that tau tends to infinite, okay? Whole square, and I have to say in this tau tends to infinite. See what happens if tau tends to infinite means this term becomes 0. So I have only root 25, that equals to plus or minus 5. So that's a mean value. From autocorrelation, this is how I get the mean. Now variance, sigma x square is given as E of x square of t minus E of x of t whole square. Okay, so how I'll get this mean square formula? So we already got this third property, okay? Third property says E of x square of t. By substituting at tau equals to 0, I'll get it. So if I substitute tau equals to 0 in this, I have only 4 here. 25 plus 4 when tau equals to 0. So I'll get 25 plus 4 because I substituted tau equals to 0 based on the third property. Minus, this is 5 is there, whole square. Either plus or minus 5 means it becomes 5 only, 5 square, okay? So answer is going to be 4. So variance is 4. So autocorrelation, based on that one problem I solved, there are a lot of problems present in the backside of Peebles. Please do it. You have to do. Now I am going for cross correlation. So cross correlation means I need to have two signals. One is x of t, one is y of t. Both are random process. X of t is random process, y of t is random process. And if I write cross correlation, this is the formula t comma t plus tau. This is same as expectation of x of t, y of t plus tau. Okay. Now next point is if x of t and y of t are jointly White and stationary. Then I can write this Rxy of tau, because the time difference is tau, is E of x of t, y of t plus tau. So this cross correlation become a function of time difference. Okay. Now next point, if Rxy of t comma t plus tau comes to be a 0 value. So you got two random process x of t and y of t, and you found that cross correlation is coming to be 0 means, then I can say that x of t and y of t are orthogonal, okay, or orthogonal processes. So x of t and y of t are orthogonal processes. So next point, see if x of t and y of t are statistically independent. If they are statistically independent, I can write Rxy of t comma t plus tau as E of x of t into E of y of t plus tau. Okay, this is what independent we have seen from first. Okay, formula. See now, this is the point. Now if I say they are independent and also jointly Whiteson stationary, then I can write this autocorrelation as simply mod x bar into y bar, because this is what E of x of t is expectation, that's x bar, and for this it's Whiteson stationary. If say means mean is constant at all places, right? So I can write it as simply y bar, x bar into y bar. If x of t and y of t are independent as well as jointly Whiteson stationary, then I can write this cross correlation function as this x bar into y bar. So properties we will see one by one. So first property is this: rxy of minus tau is equals to ryx of tau. Then mod rxy of tau is always less than or equals to root rxx of 0 into ryy of 0. Then mod rxy of tau is less than or equals to half rxx of 0 plus ryy of 0. So these are all applicable for Whiteson stationary random process. Okay, if x of t or y of t is Whiteson stationary, then I can say this. Jointly Whiteson stationary. Okay, I wrote rxy of tau. So next point, I am talking on covariance function. So what is the covariance formula we have? Cxy of t1 or t comma s, I can write it as E of x of t into y of t minus S now covariance. So here I wrote with respect to t only. So if I change this to s, okay, y of s. This is what covariance formula. So I'll write in terms of t only. Cxy of t comma t plus tau. Okay, two time intervals or two time points. Expectation of, or I can write this as autocorrelation, right? Rxy of t comma t plus tau minus expectation of x of t y of t plus tau. The covariance formula. This is called as cross covariance because I have two random processes. Okay, what is autocovariance then? I have Cxx of t comma t plus tau means I can write this as rxx of t comma t plus tau minus E of x of t plus tau. Auto, same random process. What happens if they are jointly Whiteson stationary? Okay, jointly Whiteson stationary, x of t and y of t. So I can write autocovariance as Cxx of tau rxx of tau minus mod x square, because mean is fixed, right? I made some mistake here, right? This is E, right? Here I have to write E. Yeah, here it's E separate. Here I wrote correctly, but when I am writing here I made mistake. So it will be mod x square, then Cxy of tau is Rxy of tau minus mod x mod y. This is cross covariance if they are jointly Whiteson stationary. So if you want to get variance, okay, variance if you want to get, I can write this as Rxx of 0 minus mod x square. Rxx of 0 is nothing but mean square, okay, mean square minus mean whole square. That I'll get variance from. This I'll get from auto covariance only, okay, because x only I'm taking. Then next one, covariance, right? C xy of t comma t plus tau comes to be 0. Then I can say that as uncorrelated process. So this meaning is same as Rxy of t comma t plus tau is equals to E of x of t into E of y of t plus tau. If two random processes are uncorrelated, I get cross covariance as 0, and cross correlation will be same as multiplication of their individual means. See, whatever we said till now, it's all about continuous random process, okay? Now if I take for a discrete case, discrete, I call it as a random sequence, discrete random sequence or discrete time process, these are the names you can take, okay? So I'll keep a very simple explanation here. See, I have some x of t which is a continuous signal. Then I am multiplying with some signal called as s of t. S of t is nothing but summation n equals to minus infinite to infinite del of t minus nts. Okay, and here output I am calling as x of nts. Okay, now see, I am drawing for you here. X of t means, let's say that I am taking something like this, and this impulse train, okay, it starts somewhere here with, let's say this is 0, this is minus ts, and it will go, okay, this is at ts, this is at 2 ts, and go. Now I am multiplying here at sampler. Okay, sampler, what it will do, it multiplies x of t with s of t. So output will be coming as, wherever there is an impulse, that time the values are present, remaining times the values are not present, okay. So let's say somewhere here, okay, 0, or if I take one more impulse, this will be here. I am drawing like this. I am calling this as x of nts, and this is x of t, and this is s of t. Okay. X of t into del of t, what is the answer? It's x of 0 into del of t. Then x of 0 is the amplitude, no? Area of an impulse should be 1. Okay? So it's x of 0 into del of t. This is what the property we said, right, in signals and systems. X of t into del of t minus t naught means answer will be x of t naught into del of t minus t naught. That's what I have drawn here. These values are related to x of t values only. These values. Okay? So what is this one means? This is called as a sampling circuit, or simply a continuous signal is converted into a discrete signal. Okay? Now here n is always integer, accept. N is always integer. That's why. And what about this TS? Okay, TS is the standard sampling time. Okay, TS is standard sampling time. Okay, for example, if you take a voice, maximum frequency that is present in voice is 3.6 or 3.8 kilohertz. So we'll take, let's say maximum is 4 kilohertz, and sampling frequency I'm taking as 8 kilohertz. So most of the telephone circuits now, they keep sampling as 8 kilohertz and it's fixed worldwide. Okay, so for me in the signal, I don't want to write always x of n ts because this ts is fixed and it's known for everyone. I'll simply write as x of n, that's it. That's why this n is always integer. Got it, huh? Because this ts is a standard one and everyone knows it, so I don't want to write all time. So I'll simply write x of n, and x of n is a discrete signal that is coming from continuous signal. Okay, so x of n is called as discrete time sequence or discrete time process, whatever you want you can call it. Okay, this is a simple explanation for coming from continuous case to discrete case. Again, from discrete case to continuous also we can convert using a low pass filter. So condition that is satisfies is this sampling time should be at least twice of the maximum frequency that is present in the signal. Like that we have to choose this TS. That's called as Nyquist criteria. Okay. So here I am interested only to say that x of t, what is x of nts? If sometimes x of nts is not written, x of n also meaning is same. Okay. So in your people's textbook he wrote like this. Mean is given as x of n ts. Did you got the meaning for it? He is finding for discrete case. So mean formula is this. What is the formula we have? Summation x into px of something based on the mass function you got. You can draw it. Now autocorrelation rxx of nts. This is one timing. nts plus kts. What is this? This is the second time instant. nts is one time plus delta, and delta should be always multiples of ts only because signal is present at ts places only, right? Multiples of ts. That's why we wrote kts, where this k is also integer, n is also integer. This is the second point. Okay, now you can write this one as expectation of x of nts, x of n ts plus kts. Got the meaning? Why I wrote kts? Because signal is present only at ts places only, multiples of ts only, and k is also integer. This k is also integer. Now cross covariance cxx of nts comma nts plus kts, I can write it as rxx of nts comma nts plus kts minus expectation of x of nts into expectation of x of nts plus kts. This is called covariance, autocovariance. Now cross covariance means I have to have two random process, x of nts and y of nts. Let's say two random processes are there. For this I have to write cross correlation first. What is the formula I can write? rxy of nts comma nts plus kts. Answer is x of nts into y of nts plus kts. Now covariance, cross covariance, cxy of nts comma nts plus kts. So this is equal to rxy of nts comma nts plus kts minus expectation of nts, expectation of y of nts plus kts. See, almost all formulas are similar only, but you have to keep in mind whether it's a discrete case or continuous case. So we got cross covariance. Now if I say that x of nts and y of nts are jointly wide sense stationary,
if I say that they are jointly Whitesian stationary, so what I can write? X of NTS as
some constant x bar, expectation of y of NTS as some constant y bar, then r xx of NTS comma, second point is NTS plus KTS. What will be the answer? R xx of time difference, right? KTS. Similarly, you can write for RYY case. I'm not writing it, it's just repeating. You have textbook all formulas, okay? I'm writing directly the covariance part. Cxx of NTS comma NTS plus KTS. This is equals to Rxx of KTS minus x bar into x bar whole square, because there is no y. Yes, now Cxy of NTS plus KTS, I can write it as Rxy of KTS minus x bar into y bar. See, like this, there are formulas. Please see in the page number 199 in People's textbook, okay? So we will solve some problems.